Hey everybody, and welcome to the Daily Space Weather. Lots of stuff going on again. No time to screw around. Let's get to it. You may have been paying attention to these three significant sunspot groups in the southwestern limb. They've been degrading over the past day. The likelihood of major solar flares is still there, however. They are magnetically quite complex sunspot groups. You may have also been looking at a bunch of filamentary activity around the northern hemisphere. We've captured a bunch of that as well. If you haven't checked out our Twitch channel, twitch.tv/smAsho, we captured a bunch of spectacular CMEs and prominences throughout the day yesterday, as you can see here. And you can see the time and date stamps there. If we bring it back, there was other activity as well. Prominences all around. We may have a new sunspot group forming as well. Again, twitch.tv/smAsho. Here's your colorized magnetogram. And when we did show prep, this area up here was indeed a sunspot. Also interesting facts about sunspot number progression, solar cycle progression, and more. Here's a close-up of the southern hemisphere. And we're seeing some coronal hole activity down there as well. We'll get to that in a moment. Here's a full disk view, and check out this filament up here. It's going to release right toward the end of the video. Check it out. A sudden reorganization, perhaps. Too early to really see what that is as far as a coronal mass ejection or not. Preliminary reports, preliminary indications are that there's no Earth-facing components associated with any of this activity. Here's a closer view of that same area. Spectacular filamentary reorganization happening there. Some of it most certainly ejected. If I had to guess, which I don't, I would guess it's a miss to the northwest from Earth's perspective. Just spectacular imagery there. The radial flux has actually dropped quite a ways down here. Now in the 80s, the radial flux only at 88 now, and you can see the sunspot number and radial flux crossing. Check it out. The sunspot number got all the way up to 124, I think it is there. That's the red line. The black line is the radial flux. That's a one-year chart from Solon.info. And check it out, folks. As far as where this recent progression of sunspots took us, it was all the way up here. So not that much lower than the maximum number of sunspots we saw in the last solar cycle, and it's very early. As you can see, the peak of the solar cycle is expected to not occur until around 2025. So a sudden early uptick here in the sunspot number, reaching all the way up into the 120s. No space weather storms or anything like that forecasted at the moment. And again, we don't see anything headed Earth's way as far as coronal mass ejections. Let's take a brief look at seismicity. There was at least one 6+ magnitude quake over the past 24 hours. This is should be a 90-day graph. 90-day bar graph from volcano discovery. And here's the largest quake of the past 24. This was a 6.2 near the Chile-Argentinian border, located there in western South America. Let's get to the list. Not all that much activity. A deep quake did strike Tonga. It was a 5.2 at 172 kilometers depth. Indonesia saw a deep quake at 4.6 magnitude, 149 kilometers depth. There was a quake in northern Siberia there. Nothing too exciting going on as far as earthquakes. Some additional aftershocks there in the South Sandwich Islands region. By the way, that quake at Argentina was indeed at depth, at nearly 200 kilometers depth there. That 6.2 magnitude. If that would have occurred at the surface, that would have been more like a 7 magnitude quake. Let's hope that wasn't a foreshock. It could do some significant damage. Moving on to volcanoes to see what's erupting. Suwanosejima is Flight level 080, it's producing an 8,000-foot ash plume. Dacono exploding as well. 7,000-foot ash plume over Halmahera. Pagan, Mount Pagan, exploding over the Mariana Islands. However, the volcano alert level was lowered to yellow. It's unclear whether the eruption has paused or ended. The Great Sitkin Aleutian volcano produced a new lava flow. And about a 3,000-foot plume of volcanic ash coming from that. Popocatépetl producing some volcanic explosions and a 20,000-foot ash plume over central Mexico, not far from Mexico City there. Sabancaya exploding, 23,000-foot ash plume over Peru. Please do not pole vault the caldera. Please do visit our links. Perhaps pick up some merch. The merch shops are spectacular, where we invite you to Mensa, make Earth not suck again. And we remind you that my vaccination status is none of your business, and that you probably shouldn't pole vault the caldera, etc. You can find links to all of that and the Smash team at smashamash.com on our lovely homepage. It's quite spectacular. Let's get back to space, where the GOES 16 and 17 are measuring the magnetic fields. And we're seeing some pretty spiky readings here. Earth is just about to snap into a South Pole current sheet as there's been a South Pole-oriented coronal hole growing. We'll get to it first, the top view ecliptic plane field plot. So you can see a South Pole current sheet moving through by tomorrow's daily space weather video. We expect to be in a South Pole current sheet. So look for some additional spikes in the GOES magnetometers. Here's a line of sight view along with the solar magnetometer data. And you can see some South Pole potential field surface source lines shown here in red coming through right at the end. That's the South Pole current sheet on the way. Here's a line of sight coronal hole plot, and you'll see a coronal hole forming right here, reaching up toward the solar equator. It's of South Pole orientation. This also shows you the sun's B field in blue lines and North Pole oriented coronal holes in green. The line of sight coronal hole plot. Next, our flare monitor and detected sunspot groups. Again, I still think there is a greater than 50% chance of major solar flares, largely because of the positioning of these. As large sunspots approach the limb of the sun, they are more likely to produce major flares. In any case, solar flare warning remains in effect. Coronal mass ejection warning has been reduced to a watch. And here's the GOES X-ray flux. Again, no major flares here over the past several days. Surprisingly low levels of activity, and those sunspots have actually been degrading, if you're wondering. The sunspots in the southwestern limb. No spikes in the proton flux, no surprises there. Let's take a look at the real-time solar wind. Looks like another weak coronal hole wind stream. The density spike was only up to about 23 protons per cubic centimeter. The velocity spike was a little over 500, at least to 510 kilometers per second, now subsiding a little bit. It's a pretty weak diffuse coronal hole wind stream. You can see the BTBZ, the top pane, the red and white lines there shifting around. Current conditions are solar wind density 7.2 protons per cubic centimeter, solar wind velocity 472 kilometers per second. Next, the KP index, which is up to 3. From that increase in the solar wind velocity, and largely from this negative BZ component here. If that was a little stronger, we might actually see geomagnetic unrest conditions from that, but currently only a KP of 3. The KP index is a measurement of global geomagnetism. And let's take a look at geomagnetism from the perspective of space the last 4 hours as modeled by the Space Weather Modeling Framework. I would expect to see a small reduction here in the pressure. Again, this is 4 hours of data. And the scale here is 0 to 1.5 nanopascals. That's magnetohydrodynamic pressure. If you want to read about where the data comes from, go to the Geospace Magnetosphere Movies page where we are now. Click on Details. You'll find a link to the Space Weather Modeling Framework, which tells you all about the variables used to make these calculations. Next, ground magnetic perturbations. Yes, Earth is experiencing a polar excursion. Have people on YouTube gotten you to be frightened of a polar excursion? Well, I'm here to remind you that it isn't scary at all. Your ancestors survived way worse things than a little geomagnetic excursion. Don't be a baby. And don't misunderstand the physics. That's 4 hours of data. Changes to Earth's B field, geospace delta B, shown in nanotesla. Next, a diagram of the solar system. That's where things are now. We'll advance it 1 week. There's where things will be in a week. It looks like a full moon coming on the 20th. Right around the equinox, which is going to have people scared and spooked for absolutely no reason. Next, a star chart. It's in-the-sky.org. Mine's facing the south, which is the direction of the ecliptic from we in the northern hemisphere. We've also drawn in the blue line here. That's the galactic plane. And let's do a brief cosmology segment, once again integrated into the daily space weather video. We do have playlists with hundreds of cosmology segments, and we've been saying 2 years ago that black holes don't only behave as vacuums, but also as fountains, and we'll get to that in a minute. Let's talk about a random object at the Neil Gehrels. Number 513 at the Neil Gehrels is a high-mass X-ray binary, SEER X1. So here are the X-ray outputs from SEER X1, the high-mass X-ray binary. I think that's a southern constellation, which is why I'm not familiar with it. And let's take a look at this. Now that we've looked at the hard X-rays from it, you can see it's a pretty consistent source here over the past 30 days at least, but all over the place. For some reason, it's only showing daily and 30 days. Let's see if we can look at it visually. And by the way, if you look up your favorite transients here on the Neil Gehrels Swift-Bat X-ray Observatory, if you see this link for SIMBAT, if you click on that, it'll provide another link for the CDS portal, which is where we are now. And this provides an incredible amount of information about certain objects. So this is a great catalog. And what it's telling us here is that this is probably a supernoval remnant pulsar. So this particular high-mass X-ray binary, likely to be a pulsar. Let's take a look at it here in some wavelengths. Does it show up in gamma ray? Well, not really. Here's the X-ray survey. You can see it's quite a bright X-ray source there. That's false color images there, different frequencies, red, green, and blue. Here it is in optical light. This is the Pan-STARRS survey, and you can see it's quite dark around where that likely pulsar is located. How about an infrared? And there is the thermal signature from that high-mass X-ray binary, again known as SEER X1, CIR space X1, if you want to look at it yourself on the Neil Gehrels Swift-Bat X-ray Observatory. It stands for Burst Alert Telescope. And it's at a pretty busy part of space there. You can see a lot of heat around that area. Let's talk about black holes. Now, I've been saying for a couple of years that black holes do not only provide a sucking force, but also a blowing force, as they tend to have polar jets. Ultimately, we don't know if the sun, the solar system, or the galaxy are gaining or losing mass. And in 1974, Stephen Hawking made the seminal discovery that black holes emit thermal radiation. Previous to that, they were believed to be inert final stages of dying heavy star. So, ultimately, folks, the process of stellar evolution is not understood. The idea that supernovae destroy stars is not consistent with the observations that we see, in that nearly every supernoval remnant that we see, if not every one, has a star shining bright from the middle of it. And so this has been out for a while here. I just wanted to briefly talk about this. You can find this on scitechdaily.com. There's also a phys.org article about this and a paper published about black holes exerting a pressure on their environment. So go have a read on that. And I try to call black holes massive radio sources, as opposed to black holes, which are a bunch of math in search of observations. Here's the astronomy picture of the day, which includes the small and large Magellanic Clouds there, just above the photographer here, who's holding a mirror up over a pool of water to reflect Jupiter and some Milky Way dust. And last but not least, let's talk about this supernoval remnant. What you're looking at there is the red is hydrogen and nitrogen, and the blue is reflected light coming out of the center of the supernova. Why it has such an oblong shape, well, nobody really understands. However, one of the explanations could be that it's two stars in there. And you can find this article on scitechdaily.com as well. It's a Hubble capture of the, quote, final acts, end quote, of a monster star. And we've never seen a star get born or die, yet there's a lot of conjecture about how this process works. And it's looking less and less likely that stars have some sort of nuclear fusion dynamo bomb thing inside of it, and that they have a fake surface that's held in place by a combination of gas pressure and gravity, and that would make them very unstable. Stars don't look as unstable as proponents of electric stars, nor the standard concordance model of stellar evolution would have you believe. And thank goodness, cosmology is in the process of being rewritten. It's a great time to be doing astronomy and cosmology. It's enough to make you start your own science foundation. It's what we did at smAsho.com. And that's today's cosmology segment. All right, we didn't want that to be too long. Check out our charging hazards. Here's the charging hazard scenario around planet Earth. We do see some surface charging around the Caribbean, southern Florida, Central America, southern Mexico, about to move into the Central Pacific. Satellite charging hazards caused largely by electrons there, non-relativistic electrons on the surface. Here's a one-year chart of the relativistic electrons. That's from Solon.info. And here's a 3-day chart from the GOES 16 and 17, just moderate levels here, a little bit on the low side, typical of coronal hole wind streams. Here's the electron forecast model. And NOAA forecasting for flat levels here, noted by that green box. That's the observation. Here's a diagram of Earth's Van Allen belts. Feel free to pause the video here and note that distances are shown in miles. And here's the total electron content forecast. We do see some chaotic bands of electrons once again here. Some surprisingly high levels of electron flux over places like, I believe, Southeast Asia. And you can see some orange blobs here. Not quite as high or chaotic as they have been the last few days. The current electron chaos is subsiding a little bit. You're most likely to see GPS errors around the equator at noon. And this gives you some better insight into that. The total electron content forecast. Here's a diagram of the atmosphere as well. A different diagram showing you things like penetration of electromagnetic radiation and the location of the F ionosphere layer, which is our next slide. Here's your ionogram for the past day. What you're looking at is vibrational frequency, and we do certainly see some high-frequency anomalies in places like the southern Atlantic Ocean and over South America. And some low-frequency anomalies on the night side. Anyway, there's the latest image from 9:45 Universal Time. Here's the anomaly map showing you departure from 30-day median in megahertz. You can see those blue blobs there and some red blobs over the central Atlantic. So some large gradients there in the ionosphere. Megahertz are 1 million vibrations per second. And this is showing you anomaly in megahertz. So here's the latest image there. Also 9:45 Universal Time. Things looking pretty normal at the moment. Do you watch our space weather videos but not our meteorology segments? Well, maybe you should. They're pretty spectacular. Here come bonus features. Not that bonus feature. This bonus feature, the El Teide ground-based solar observatory in Spain. So we do see some prominences here. This filament is largely no longer in the Earth-facing zone. It's either ejected, collapsed, or reoriented itself. You can see that kind of vanishing there. Also, we'll be looking at this sunspot. It was a sunspot when we did show prep. Let's take another look by pressing refresh. So here's the latest intensity gram. And I do see a tiny hint of an umbra there. So it looks weaker than when we did show prep. It may not be a sunspot. Again, these have largely degraded here. Pretty much all of them have degraded. This one at this southern latitude here has actually completely vanished. It's now a plage. And there are those major groups. Those are still capable of producing M or X class flares. Don't be surprised to see it happen. There are the fields associated with those. And here's the possible new sunspot growing. Not looking particularly strong. And we'll close out the video here with some additional composite imagery. This is 304 and 171 angstroms ionized helium and iron. Great view of that filament motion. And again, we've reduced the coronal mass ejection warning to a watch, although we've kept the solar flare warning in place. Here's 171 angstroms alone. And we'll close out today's video with a close-up of these sunspots. Quite spectacular, and enough to bring us near the solar cycle 24 maximum, along with other groups. There was a point where we had like 6 named sunspot groups, folks. So that was pretty interesting. And we'll be keeping an eye on this. And when I say eye on, the pun is intentional. May that solar wind be at your back.